across this question in exam, how will you solve it? The question says 1.0 gram of Caco3, that's limestone, was reacted with what? Excess 0.1 mole molarity ACl. Okay? At the end of the reaction, listen, Caco3 reacted with ACl, but the ACl was in what? In excess. So at the end of the reaction, the acid still left unreacted required 25 of 0.1 what? Molarity Na2 what? CO3. Okay, to neutralize it. Now, here's the question. What was the original volume of the word of the acid? So the question is very simple. Some of the acid reacted with limestone. Some of the acid reacted with Na2CO3. So what we have to do is very easy. Let us calculate for the volume that reacted with CaCO3 and also calculated for the volume that reacted with Na2CO3. Then we have our what? Our answer. Now look at the chemistry of the reaction. The first reaction number 1, is when your ACl reacts with Caco3. And here's the product. ACl reacts with Caco3, here's the product. So what do? Let's take it one after the other. Let's start with this. Look at this class. You have 2 moles of the acid reacting with 1 mole of Caco3. So you have 2 moles. I'm starting with number 1. You have 2 moles required what? 1 mole of CaCO3. Please be careful. This is your ACl, okay? So you have 2 moles of ACl, you have 1 mole of this. Watch carefully. Now, we are now going to look for the number of moles of ACl that must have reacted with 1.0 gram of the CaCO3. So, but we need the moles of this guy so that we can compare it. So how do we calculate for the number of moles of CaCO3? Remember that number of moles is mass over what? Molar mass. So we have number of moles is equals to mass of CaCO3. What's the mass? 1. Good. Over molar mass of CaCO3. What's the molar mass? They told us that CaCO3 is what? 100. So we divide this guy now by weighting at 100. As we do, we have 0.01 mole. So from this guy given, it is 0.01 mole of Caco3 that reacted with the acid. Okay, so we have what mole of the acid, which is S mole, will react with what? 0.01 mole of CaCO3. See, this is what we have. The first one is by the reaction, 2 moles to 1 mole. Are you seeing it now? Now, we now calculate the number of moles of this guy, which is this. So what mole will react with this? Don't forget we are trying to determine weighting, volume. So we need the number of moles first, so before we can determine the volume. So what do we do now? Cross multiply. So you have 0.01 times 2, okay? Then x times 1. So x will give us 0.01 times this 2. That will give us 0.02 moles. So we found out that number of moles of ACl now is 0.02 moles. That's interesting. So we have been able to calculate for the number of moles of ACl that reacted with Caco3, which is your limestone. That's what we just determined. Don't forget, I'm talking about reaction 1. So this is what we have now. We have calculated. Now don't forget, I'm looking for weighting and volume. Remember that number of moles according to concentration, number of moles according to concentration is equals to weighting CV over weighting at 1000. Yes, but do we have the number of moles of the ACl now? Yes, without solving. So you have 0.02 equals to concentration of the ACl, 0.1. So you have 0.1 V over weighting 1000. So what do we do now? We cross multiply to give us 0.02 times 1000 is equals to 0.1 weighting V. Divide both sides by 0.1. Divide here by 0.1. Let's see what we are going to get as the volume of the HCl that reacted with Calco 3. So 0.02 times 1000 will give us 20 over 0.1. So 20 over 0.1 will give us weight now 200 what cm cube. So this is the volume of HCl that reacted with CaCO3. Don't forget, we are looking for the original volume of the acid. Some of the volume went as to react with this. So this is just for the volume that reacted with what? The Calco 3. So we should be looking for it in the what? In the option. Let us now calculate for the volume that reacted with what? 25 cm cube of 0.1 mole per dm cube Na2 what? CO3. We are going to calculate now the volume of the acid that reacted with the other words, the other weight in our base. Okay, so we have calculated the volume that reacted with the first base, which is what? 200. So let's calculate for the volume that reacts with the other base. Let's do that quickly. Remember that they gave us the volume of the other base. So volume of the base is 25 weighting cm cube. They gave us concentration of the base Cb to be what? 0.1 mole per weighting per dm cube. That's so interesting. Okay, did they give us the concentration of the acid? Yes, see am here, 0.1 mole per dm cube. So we have Ca is 0.1 mole per weighting per dm cube. Did they give us the volume of the what? Acid? No, we are looking for the volume of the acid that reacted with the other base. So we have Va is what? Unknown. Moreover, class, listen to me. Remember that the mole ratio is given in the equation. So the number of moles of A is equals to what? 2. Number of moles of B is equals to what? Is equals to 1. So what do we do now? Very simple. CAVA over CBVB is equals to NA over weighting NB. Okay? Now CA is what? 0.1. VA, we don't know VA. All over CB is what? 0.1. Okay, VB is what? 25. Equals to NA, which is what? 2. NB now waiting at 1. So what do we do? 0.1 times VA. Okay, I think 0.1 can cancel 0.1. So that one will be out. So what do we have? We have VA over weighting 25 equals to 2 over 1. So we cross multiply like this. So that VA will give us 25 times 2. So VA will give us weighting now 50 weighting cm cube. So if we have 50 cm cube, we are looking for the original volume of the weighting acid. Good. So you have 50 here, and here you have 200. So we add it up together, you have 50 plus 200 to give us weighting 250 what? Cm cube. So the answer is not A, it is not B, it is not C. The answer is weighting D, which is what? 250 cm cube. If today is your first time for coming across this YouTube channel and you are here to subscribe, please do well to subscribe and don't forget to like our video for more content. Thank you very much. I'll see you in my next video.